Okay, so there's definitely going to be some background noise for this one because it's Saturday night. We got the family party going on. I've snuck away to do a couple videos here. So what I'm doing is problem 15.20, chapter 15. And I pre-wrote a constant on here which I'm going to need. And the question is, what's the 0-point energy of helium in a box, a one-dimensional box, which has a width of 1 centimeter. That's what the question is. What's the 0-point energy? That's part A. This is a helium atom. Okay, so we remember from a particle in a box that the energy of a particle in a box is h squared n squared over 8m a squared, right? Where a is the length of the box. So a is equal to 1 centimeter, which I'm going to convert to meters right away. 0.01 meters. And we know what h is. N is equal to 1 because it's the lowest energy level. It's 0-point energy. You can look that up if you want to attach some more significance to it. And the mass, I guess, is the only other thing. This is not the mass of an electron now, so if a person got this wrong, perhaps they put the mass of an electron. This is the mass of a helium atom, which is roughly 4 AMU, 4 grams per mole. And we know that for every AMU, it's 1.661 times 10 to the negative 27 kilograms, which has to be in kilograms, obviously. Okay, AMUs cross out, so that's the mass. So I think you see where I'm going with this. This is going to end up being 6.626 times 10 to the negative 34 joule seconds squared times 1 squared, and that's dimensionless, so let's leave that off, times 8 times 0.01 squared times 4 times 1.661 times 10 to the negative 27 kilograms. That's in the front of the book. That's just a constant. I wouldn't expect you to know that 1 AMU was 1.661 times 10 to the negative 27 kilograms. All right. So having said that, let's calculate what this is, and there will be our answer. 6.626, 34, enter, squared, okay. 8 divided by 0.01, enter, squared, divided by 4 divided by 1.661, 27, divided by. Okay, so this comes out to be 8.26 times 10 to the negative 38. What are the units? So it's E, so it's joules. And some other videos I've gone through, and I think it's wise of you to do this. You need to do this a few times. Go through and look at these and make sure everything cancels out. This is meters squared, right? Because that's that right there. That was in meters. That's in kilograms. So you need to go through and make sure that joules squared, seconds squared, divided by kilograms, meters squared gives you joules. It does, but all right. So that's part A. Part B is compare this to KBT at 300 Kelvin. All right. What's the significance of this? Let me not say for this video what the significance is, but there is a significance of KBT. And you should be thinking about that. I've said it once or twice in class, but it's an easy thing to miss. So K, I pre-wrote that here before the video. 1.3, that's just simply 1.381 times 10 to the negative 23 joules per Kelvin times 300 Kelvin gives us 1.381 23, enter 300 times 4.143 times 10 to the negative 21 joules. So the task for part B was simply compare them. KBT is much larger than 0-point energy. There's a point to be made from here, okay? Why is that a decent question? And that's, I'm going to leave that for you to think about. Hope that's helpful. Good luck in your studies.